Today, we're going to understand oxygen hemoglobin dissociation curve. The air we breathe in contains 21% of oxygen and 79% of nitrogen. Oxygen is primarily transported throughout the body in red blood cells, which contains hemoglobin that carries the oxygen from the lungs. Oxygen will bond with the hemoglobin molecules and will be released to the tissue cells. Hemoglobin is made up of 4 polypeptide chains. Each polypeptide chain has hem group that contains iron when oxygen binds. It means that one hemoglobin can carry 4 oxygen molecules. What is the importance of understanding oxygen hemoglobin dissociation curve? First, it is to understand how our blood carries the oxygen and releases it to the tissues. Second, it shows how saturated the hemoglobin is with oxygen at any given partial pressure. Last is to know how saturated the hemoglobin molecules depends on whether it has high or low affinity. At first, it is difficult for oxygen molecules to bind with hemoglobin, but after the first bind, the hemoglobin undergoes a conformational change in shape which makes it easier for the next oxygen molecules to bind with hemoglobin. But as the hemoglobin becomes more saturated, it's going to be harder for the oxygen molecules to bind. There are 2 types of affinity. But first, what is affinity? It is used to describe oxygen attraction to hemoglobin binding sites. It is the term meaning changes of variation of pH, temperature, carbon dioxide concentration, and 2,3-biphosphoglycerate. High affinity is when oxygen can easily bind to hemoglobin but struggle to be released. Low affinity is when oxygen struggles to bind but can be easily released. On the graph, the oxygen hemoglobin dissociation curve is a sigmoid or S-shape that represents the relationship between oxygen concentration and percentage saturation of hemoglobin. It describes the relationship between the available oxygen and amount of oxygen carried by hemoglobin. Once the partial pressure of oxygen reaches 60 mm of mercury, the curve is almost flat. 60 or more are usually considered adequate, but less than 60 is steep and small changes in the partial pressure of oxygen greatly reduce the hemoglobin saturation.